Hi, so there are only two students right now. Okay. So if anyone has any query from the previous tutorial, can ask.
Yeah, good afternoon, Sharon here.
Yes, yes.
Yeah, actually, this diagonally dominant, I think that one question was that it is strictly diagonal means even equal to, we should not consider. I think it should be strictly greater than the other two, right?
Yeah, yeah, yeah.
Okay,
Means
that is
if
one.
it is written as diagonally dominant, it should be greater than equal to.
If it is strictly diagonally dominant means only
Yes,
equal to
that's
is
right.
not there. It is strictly greater than. Yeah,
Yes, yes, yes.
that was the only one error I made. Okay.
So you have submitted assignment 5.
Assignment 5, 2. It is going on
Yeah.
currently. Yeah,
Okay,
working,
that's
working,
fine.
working.
Okay, so let's start. Maybe we can. I just share the screen. They are able to. We can have some. So we will start with some previous year questions of assignment 5. So, okay, so these types of method, Gauss-Seidel, Gauss-Jordan, Gauss-Jacobi methods, you have not studied, right? Or you have studied in your lectures? Okay,
Gauss, Jacobi, Gauss, Seidel, it was there.
yeah, yeah. Okay, so you know them.
Yeah, this fifth week lecture, it was taught.
Okay, wait a second. Now this is coming like this one. It's coming like this. Is it? Yeah, that's good. More. No, this is not. Wait a second. I just. This is not visible. Just share the screen again. Can you see the screen? Okay,
Yeah, visible. Yeah, visible.
yeah, I just switch if I want to switch like this, maybe. Okay. So first question is based on Gauss-Jacobi method. So you know this method, right? Or I recall first, maybe. That would be-
You can just recall.
Yeah, yeah, yeah. This book you are following, or
Yeah, I have downloaded. Yeah.
okay, so there are. This is okay. So this is the page number. You can see that page number 92.
Yeah.
So this is the Jacobi iteration method. Okay, I write something there. Tutorial 5, and we have, okay, this is cause. Weaver. Are you able to see my what I'm writing?
No, not visible. Only the other screen. PDF files.
Oh my god. Okay, wait a share the screen. Now,
Yes,
now
visible.
it's
Yeah.
visible,
Yeah,
right?
yeah, yeah.
Okay.
Visible. Both we are seeing. We can see. Yeah.
So you are given some system, okay, AX equal to B. Let me write out this. You are given some system AX is equal to B, okay, and you have the matrix which is given by, let me see the entries of their A11, A1n, okay. So let X is basically X1, X2 up to Xn, and B is B1, B2 up to Bn, and A is like ways you define A11, A12, A1n, and like this you define A21, A22, and A2n. Similarly, AN1, AN2, ANN. Okay, so what does AX equal B simplification gives? This one gives like this, A11, right?
Yeah, clear. Yeah.
And similarly, AN1, X1 plus AN2. Right. Okay, let me admit people are coming. All right. So you want to find the value of, so there, how many equations are there? Are total n equations, right? And n unknowns. So are you able to hear me?
Yes, yes. Yeah. Please go
Okay.
ahead.
Okay. So you can find out the value of x1 from this equation, right? Like this way, I just show you. Okay. So use so from this, I don't need to write anything. A11 x1 is written like this way. Do you understand how these equations are coming? Just directly substituting, finding the value of A11 x1 and this shift to the right hand side. Okay.
Clear. Yeah.
Yes. Then what in Jacobi iteration method we do, like we try to find out the value of x1. So okay, I just explain it fine. Okay. So x1 is what? P1 minus A12, right? This is
Yeah.
your x1.
Yeah.
And similarly, you go in this way. You try to find out what is x2, and your x2 is basically, so once you find out x2, then you can b2 minus a22. Okay, b2 minus a21 x1 up to minus a2n xn divided by a22. All right, and you use, okay, so this is x1 basically. So whatever this value you found out in x1 in first step, you are using this value in your previous step, is it? No, it's not in the case in this, I think so. No, it's not. Okay. So you are not using a base. So what happens in Gauss-Jacobi method is that you give an initial seed, right? You start from some vector, say like you start from 0, 0, 0 or some vector, right? And then this is x1, this is x2, this is xn, right? Then you try to find out the value of x1 by substituting these vectors. This is your first iteration. You substitute x2, xn to be 0, and you find out the value of x1, x2, and like this in this x2 and xn. Are you understanding this? It's quite complicated to make you understanding this way.
Yeah,
Is it?
it's like we are putting the initial assumption, we are
Yes.
substituting in all the steps and getting the values.
Yeah. So in this, what they are doing is that it's a general step actually. So x1 k plus 1 is what? X1 after first iteration is just using the values from the previous iteration, right? So if k is 0 here, then x1 1 is basically minus 1 upon a1 1, a1 2 x2 0 plus a1 3 x3 0 and xn 0. And you know the values of x2 0, x3 0 and xn 0, whatever the initial seed you provide, right? So similarly, you find out all the values here. X1 1, x2 1, xn 1. And once you get those values, then you try to find out the next iteration and so on. Okay. And there is a there is an easy way to do that. Like, so this can be xk plus 1 can be written in this form, where h is a what you call as iteration matrix. And you check the eigenvalues of h. If they are less than 1, then you say that this is going to have this method, Gauss-Jordan method always converges for any value of x naught, right? And if this matrix H, okay, so if A is also diagonally dominant matrix, then in that case also this Gauss-Jordan method converges. Do you know all these from the lectures? Convergence?
Yes, yes, yes,
Yeah,
yes.
okay.
That is
So
the necessary and sufficient conditions.
yeah. So we can do some examples for there. Okay. Yes. So first question. Consider the following equations. Using this as initial guess, the value of x1 after 3 iterations of Gauss-Jacobi method is. Let's try to find out this. So we just take snapshot of this one. Snap. Yes. So first question. So how do you start with it? Okay. So what is the value after first iteration? So you are having this one and okay, we start with like this. X1 is basically, okay. So we have given to you this value initial guess x1, x2, x3, x4. Initial guess. You have to solve with me this one. Okay, so initial guess is just x1 is equal to 6 plus x2 minus 2x3 upon initial guess is x1, x2, x3, x4. It's 0, 0, 0, 0. And this is the first iteration. So what is the value of x1 after first iteration? X1 is 6, right? Understand? How?
Yeah. Actually, this can we see this equations on screen because that is going faster. X equal to 6. Yeah.
Yeah. So it is after first iteration. Okay, these are 0 MTD. Okay, so what is x2? 1. What is x3? 1. Tell me once. I will verify it once you verify this. Tell me these things. Okay.
Yeah. Older the equation. Yeah. Please hold. Yeah.
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 Yes.
The previous one just 6 by 10 is it is 0.6, no? Like
What?
no, the x1 when we are shifting, it will be 6 by 10, no?
Wait a second. Yeah. Sorry.
So it should be
It's
zero point
fine.
0.6.
Yeah.
Okay.
Use it. So it is the first iteration, not third one.
Yeah, this is first. X2 is 25 by 11.
Okay. And what is X3?
25 by 11.
Are you sure this is right?
Yeah, 25 only because other numbers are 0 only, no? Because this we
This
should
is
not take
easy.
easy. Yeah, the other one only we have to
And
take it from the.
X3 is minus 11 by 10, is it?
Yeah, X. Then X3 is minus 11 by 10. Yeah, because all other terms are 0. So it will be say
And X4?
X4 is 15 by 8.
Yeah. So you find out these first iteration. Now you can find out the second iteration, right?
Yeah.
So second iteration is just, how do you find out the second iteration?
Same we have to. This will be our initial guess then.
This will be same like, okay, so I just write the closed form in the formula. X12 is what? So these are X11. So X12 value is 6 plus X2. 1 minus 2. Right? This one.
Yeah.
So you can substitute this, and you get second. Like this X22, X32, and X42. So you can do that, right? This
Yeah.
point.
Yeah.
Okay.
So here just the question is like which point up to 3 iterations we have to go.
Yeah.
So what is the value of X1 up to 3 iterations? Okay, fine. Then we not even go for X2 and X3 also.
Yes.
So only X1
So
we
you
need to
can do
do.
this. It's
Yeah,
just
yeah,
easy.
yeah, yeah.
The next question is about the Gauss-Seidel method. So, okay. So you know the difference between Gauss-Seidel and Jacobi method? Do you know that?
Maybe in like here we have to first step whatever the value we are getting, that should be
Yes.
the initial guess in the second one. Like we should substitute in the second equations instead of going as 0. Now we every step we are going as a 0 first step, iteration. So there it will be like we can substitute in the next equation immediately the first value to converge faster. Maybe I am not
Okay, so
explaining
what
it
you are saying
clearly.
is that the earlier thing is like this one. X1k plus 1 is just B1 minus A1 2 X2k plus 1 X2k minus A1 3 X3k and A1 and Xnk, right? Divided by A11. So now you are saying that to find out X2k plus 1, what you have to do?
This
What is,
X
so it should be B2 minus A11 X1 A. Is it K or K plus 1?
K plus 1 we can go. No? Yeah.
Yes. And other things, A23. It is
A
like,
two.
I think, 2. A23, X3, K, and A2 and X and K, right?
So whether it should be K only for one or okay, that only it will come correct. You know
This
that
one,
okay.
A22.
Yeah. So we have only one for X1 only we are having K plus 1. So that alone will come in the next step.
Yes,
Okay,
because X1K plus 1 is already find out. But
find
other
out,
thing.
find out. Yeah.
So how do we find X3K plus 1? You will use X1K plus 1 and X2K plus 1 in the next step, right?
Next step will be two values we will be knowing.
Yeah. And this will increase it further and going on.
Exactly. So convergence will be faster, likely faster.
Yeah, seems. Solve the following equation by Gauss-Seidel method up to 3 iterations and find the value of x. So it's a similar kind of question, but we can try it for the first iteration. Okay. So let me just Yes. So in this, how do we do it? Tell me. We try to find out till uh, so it's the similar question or different one?
Initial guess.
So we try to check which in which the okay, so what is the solution of this equation? Can you tell me by hand? And we try to check which solution, which method converges faster. Okay. Analytically, like, can you tell me the solution of this equation? Okay, tell me this one first. The solution of this equation. So how do you find the solution? Try to find out the inverse of this matrix, or you use any other method. What is the solution? What is the solution of this system? Is it 9 or it is 1?
Yeah,
Just
1 minus 6, 2. Yeah.
just calculate this XYZ value and we will check which method is good. Just 5 minutes, check it. Find out the solution. Wait a second, I just check it. Just the inverse of solution of system of equations. So what the equation is 4x. You can use any calculator, maybe. Eight plus 2z. Six, 5. Okay. And third equation is x minus 2y. Okay, so this is not an equation anymore. Children. Yes, so the solution of this equation is 40 minus 28 minus 86, and yeah, so xy z is approximately okay. Now we try to do using Gauss Jacobi method. How does this? Okay, Gauss Seidel method.
Sir, it is 7.4228, not 7.0422.
Are you sure?
Yes, correct.
Yes,
Last
yes.
value.
Yeah. So you have computed by hand or what?
No, sir, by using MATLAB.
Oh, okay. So this is thing. Okay, so let's proceed this. So what is the value of let me see the assignment. How many methods we are having today? We don't have much method actually. This is like okay, this is not so we can spend some time. Yes? Okay. So what is the value of x11? Calculate it. X21.
That is 10. X1 is
Have you
10.
calculated using Gauss-Seidel method?
Yeah. X1, anyway, first iteration, X1 will be with the 0 only. So it will
Okay,
be
yeah,
10.
yeah. So that will be 10, right? Second
Yeah.
one
Second one,
will be minus 20, 28 by 6, right?
no. 28 by
No,
6,
yeah.
again, the 10 will come here. It will be minus
28 by
30.
6 minus 10, is it?
No, that should be in the numerator, no? So the x value will be in the numerator, so it will be minus 30, sorry, 38 by 6.
Wait a second. Minus 28 minus 10. Okay, so it will be 38 by 6, right?
Yeah, 38 by 6.
And what is x31? Just try to calculate. Minus 86 plus 2 into 38 by 6, right? Okay. Minus 10 divided by 12, right? What is the value of this? Yes, what is the value?
That is
Minus
minus 538 by 36.
minus 38 by 36.
No, 538 by 36.
5.
Yeah, 538 by 36.
Are you sure this is correct? Minus 10. Yeah, I believe. So what is this approximate value? What type for?
It's 14.9. 14.94.
Mhm.
It's 14.94.
And 38 by 6 is, so we have exact solution is like this. Okay. So what
6.33.
6.3.
Okay.
So what I would say is I got a call maybe. Yeah. So try to find the iteration value at second iteration and third iteration and tell me this. Like x2, x12, x22. Just solve them now and
So only that
it's
X we need to concentrate.
yes. X13, I will ask this. You know how to calculate these, right? So you try to calculate these values. So we try to check which method is good. So this is by, firstly, we are checking by Gauss-Seidel, okay? Then we do with Gauss-Jacobi. So just try to find out these values for just checking point of now. So I show you the equation. Just take time for 5 minutes and try to find out these values as fast. we find out? I think first value is not correct. This value is, yeah, this is not correct. So we have minus 6.944.
Yeah, 6.944. It's a mistake.
And
Yeah.
what is x12?
X12 is 13.0115.
115, are you sure? Or 139?
Okay,
Just check.
115. Yeah, 1 second.
Just check these days. And I'm writing.
Hello, sir. Excuse me.
Yes.
Sir, we have one doubt, sir.
Yeah.
Sir, what is mean by diagonally dominant?
You were not in the previous tutorial?
We are there, sir. Actually, according to the some standard
Yes.
textbook, that
Yeah.
taking as a greater than or equal to, sum is greater than or equal to.
Yes, yes. It's greater than equal to, yeah.
But when we given the assignment, the last assignment, fourth assignment, we marked that one. They given a wrong.
What they have written, like they have used
Actually, if it
strictly
is
word.
422, strictly. They
So if
given
they
the
are,
three options, which of the following matrices are diagonally dominant?
they have not given strictly.
They only diagonally dominant. They asked which of the following are. They didn't mention the strictly at all.
No, madam, it was there, I think. Strictly was there.
Strictly. It was there
Yes, they have-
strictly, sir.
Yes, madam. Yes, madam. It was there. Strictly diagonal dominant like that. It was there.
And sorry, you
So I
check.
also selected a wrong option only, but today first thing that only I discussed. I also
just
selected
check
option both options, both A and B. But actually, since they
Okay.
strictly is there means there is no equal
Yes,
to. Yeah.
yes. Okay. Thank you. Thank you, sir.
check, verify that these are correct, or what is the, yes. So let's see which one is speaking. Okay, so these are by Gauss Seidel. Find out. And you have, I think, the value of x 5162. Yeah, so yes. So have you found out these values, or I'm wrong? These are correct, right? Okay, so we try to find out using Gauss-Jacobi method now. Now check with Gauss-Jacobi. By Gauss-Jacobi, what are the values? And tell me which method is good. Is this matrix diagonally dominant? Is this matrix diagonally dominant? The A matrix here.
Yes, sir. It is diagonally dominant.
Yeah, you can see that. So this method will always converge, right?
If they ask strictly, it is not strictly dominant, sir.
Yes, it's not. In the first one, you can see.
Okay, we didn't observe the strictly word, sir. Okay.
Okay, so Gauss-Jacobi say you just need to find out these again. X11, X21, X31. Tell me these things. X21, X32. I just want to compare both the methods actually. So I just want to show you. Okay, so X13, X23, and X33. Yeah, find out. This is the equation. Take 5 minutes.
Can you see your this X22 values?
Yes.
Freedom.
Wait. Tell me which is.
Yeah, okay. The 13 is okay. X22.
These are correct. You can check it.
Sir. Hello, sir.
Yes.
Hello. Sir,
Yeah.
one more doubt, sir. Sorry.
Mm.
In the assignment, they given x1 is equal to 3 first equation. That means 300. Same for the Gauss seidel and Gauss elimination only. That means x1 is always it is fixed. No, it won't take any other value. No, if it changes also, iteration will be the same only no, for x always.
What you are saying, if you change the first initial seed, then the iteration may change, right? Depend on the first seed. First.
X1 is equal to 3. They're not given any, it's not an equation of anything. Only x2, x3 coefficients are 0.
So what they are giving in equation is like that. Here, x, y, z is 0, 0, 0.
0, 0, 0 only.
Yeah. So this is the initial point, right?
Initial point is 0, 0, 0.
Yeah. And you with the help of this initial guess, you need to find out the first iteration value, second iteration value, and third.
Yes, sir. In that x1 is equal to 3 is the first equation.
Yeah.
Second equation will get us some x2 is equal to 9 minus 2x1 minus 2x3 whole by 1 by 2 something will get minus.
So you don't know how to apply these methods?
That means my doubt is
Yeah.
x1 maybe initial guess may be 0. Every time it will get the next onwards, it is 3 only. Now it is fixed value in such a case.
Yeah, it's fixed. But it can be changed. You can. It depends.
How it will be changed, sir? If I change all x1 may not be changed. Always it is 3 only.
If it is given in the question, then it always it's 3, right?
The equation itself, first equation is x1 is equal to 3. Diagonally dominant 300.
My God. Okay, so tell me by relation to this question. Question number 2. Here xyz is given as 0, 0, 0, right? Like in your question, xyz is given as 300, right?
No. Initially is 0, only.
Yeah.
Equation is x1 is equal to 3, 2x1 plus 5x2 plus 2x3 is equal to 9.
Okay. X1 is equal to 3. You are saying about this equation.
First
This is the first equation. Okay.
Instead of 2, 4x.
Yeah, then x1 is always 3. Yes.
3 only, no? That's a fixed only.
Yes, it is fixed.
It won't be changed, no? Even
No,
it is negative.
it won't be changed. It won't be
Gauss
changed.
seidel or Gauss Jacobi also.
What's the point in giving this equation? Like x1 is 3, it will be a 2-variable equation. 2-variable system only.
2-variable system only.
Yes. So you need to start with only 2 points. Then you don't need to start with 3 values. It's just a 2 by 2 system.
Yes, sir. Okay.
Yes.
Okay, sir.
You can.
Okay. Thank you.
Okay, so by Gauss Jacobi.
Every time you are giving a 3 to 5, na, at that moment we are having the classes, we are missing your classes, sir.
Okay, you are missing our tutorials, is it?
That is the main problem.
Don't miss them.
We are getting so many doubts. How to clarify that one? Suppose if you miss the class, no chance, sir.
You can email me once.
Email. What is your email, sir?
I've sent the in earlier tutorials. You can look at the recordings.
Okay.
In the last May we find out.
Okay. Okay. Thank you, sir.
Yeah. Just find out the by Gauss Jacobi method. What are the values, and we will compare them.
Gauss Jacobi means always we have to use the last approximations only. Whereas Gauss seidel, latest approximations will use.
Yes. You're saying anything? Okay. I just write that maybe. Okay, so what are the values now? Tell me. X11 is 10, X22 is 4.667, is it? And minus 7.16. X2 is 11.077083. And X33 is 11 point. Yes. So which method is good? Tell me. Here you are getting these values. Copy. So it is by Gauss-Seidel. And next one is by, we try to find out the errors basically. By Gauss-Jacobi, you have this. Okay. And what is the exact values? What are the exact values? Are this one. Okay. Okay. So which one is good? Gauss-Seidel or Gauss-Jacobi? Tell me. For X1. X1 value is closer to like if you calculate the diff. Yes,
Yeah, it is close to Gauss Jacobi, no?
Jacobi, right?
Yeah,
X1 is
Seidel it
close
is
to.
slightly going away, like slightly diverging.
Wait a second. Yeah, it's slightly diverging for Gauss-Seidel method. And for okay, second one.
Same. 4.2, another one is 4.0.
Wait, second one is more good for Gauss-Seidel, right? Can you
Okay,
see
okay.
that?
Jacobi,
Yeah.
Jacobi, okay.
Second one is more good for Gauss-Seidel. And third one?
7.4.
Third one is also more good for Gauss-Seidel, right?
Yeah.
So Gauss-Seidel is good method, I think, for because it is using the previous updation steps and it is helping to convert them faster. And this effect is seen over the not in this value much, but in the other two values. Like if you proceed further, maybe.
Yeah, just this actual values, how it has come, like inverse you are telling me initially.
Okay.
It's not
This, how I calculate these? You are asking that?
Yeah. Just the inverse of this.
Yes,
Matrix.
inverse and this just to check.
Okay.
You can calculate by Gauss elimination method. You know that, right?
Yeah. Okay.
I'm not doing that. But yeah, so I just want to show them virtually anything. Anyways. So this method always converges because A is diagonally dominant, right?
Yeah.
And there is a rule. Let me show you. So you can solve it like this also. This is also easier way to solve these equations. But to check the convergence, you try to find out what is the H, and there is a formula which says that, wait a second, it takes time to come out. Showing anything here, taking time to. Okay, so there is a thing that says that if and only if each eigenvalue of this iteration, absolute value of eigenvalue of each iteration matrix is less than 1. If this is the iteration matrix and you calculate eigenvalues of H. Okay. And if these are less than 1, then we say that Gauss-Seidel always converges. This is necessary and sufficient condition. Okay. So if the matrix is not diagonally dominant, you can check this thing. Anyways.
But still we can interchange the rows, man.
What?
If it is not diagonally dominant also, we can interchange the rows and make it diagonally dominant.
Yes. You can make every matrix is diagonally dominant, is it?
Pardon?
Every matrix is not diagonally dominant, right?
Correct, correct. Yeah, yeah.
Yeah. So I'm just going to this. Okay. To ensure that the following system of equations converges using the Gauss-Seidel method, one can rewrite the above equation as follows. So which is the more appropriate way? Now you will tell me to write this. How do I ensure that this method converges, Gauss-Seidel method, for this system of equation? To make that diagonally dominant, right? And which option follows the diagonally dominance? Yes, that's what you are saying, that we can interchange the equations. Yes, tell me. So if you can see that the last option is good one. So C option is good one. And this option is also good one. And the first option is not good. Right? And this is also
So
just
it means like we can give two answers. Is it like that?
Yes.
No, is it like
Yeah.
two options are correct?
Yes. Two options are correct in this case. Okay. Strictly diagonally dominant. Now you will tell me which is strictly diagonally dominant. A matrix in this case. First one, A. What is A? 4, -1, -1, 3, 1, 2, 2, 5. Is this strictly diagonally dominant? Yes. Second one, A. 4, -2, 1, 1, 0, 1, and 3, -5, 1. Is this strictly diagonally dominant? No. Third one, A is this -2, 1, 1/2, 1 -2, -1/3, 1, 0, 2. Is this strictly diagonally dominant? Third one, yes.
Yes.
Yeah, I know that. So if this is an eigenvector of this, the eigenvalue corresponding to eigenvector is. So have you studied some other methods to find out eigenvalues and eigenvectors?
No, you can recall.
PDF is not opening.
Yeah.
I want to recall this. Okay, so there is, I think, this will come in the next tutorial class, maybe. This power series method, and are these methods? Yeah.
Yeah. Yet to there. It is not there in the current session.
Yes, it's not there. So, but you can look at this. But what is an eigenvector and eigenvalue? Do you know this? Can I recall it?
Yeah. Yes, please. Yeah.
Okay, so let's how do you find the eigenvalue of a matrix? So it's just easy. 8 minus 4. A is 8 minus 4. Right? And you have A given by A is this, and So how do you find the eigenvalue? Determinant of A minus lambda I should be 0. So 8 minus lambda minus 4, 2 minus 4 minus lambda 2, 0 minus 2 minus 4 minus lambda. What is the determinant of this? So you can find out the determinant, right? By this way. So it will be 2, 8 minus lambda plus 8 minus 4 minus lambda minus 60 equals to 0. So you can solve it to find out what is lambda, okay? All right. How many students are there? 4. Okay, so you can, you know how to find the eigenvalues, and so once it is given in the question that this is an eigenvector of this minus 4.5 minus 4.1, right? 4.5 minus 4.1 is eigenvector. So what is an eigenvector? A vector non-zero vector x such that Ax is equal to lambda x, right? A minus lambda I x is 0. So which eigenvalue corresponds to Ax is equal to lambda x, right? Where x is an eigenvector. Okay, so what you do is try to multiply A by x. So what is Ax? 8 minus 4, 2. 4020 minus 2. X is minus 4.5 minus 4. Yes, what is this value? Calculate it. What is the value of this? This is 8 times minus 4.5 minus 16 minus 2. So what will be the
That would be plus 2, not minus 2.
yes? What is the answer?
So it is minus 18. Minus 18.
Minus 18. Are you sure?
Yeah.
Yeah,
Yes,
yeah.
yes.
Minus 18, minus 16, and 4.
Okay, this is right. Minus 18, minus 16, and 4. Right. Okay. So can you write it as multiple of this thing? So lambda is what? It should be 4, right? It can be written as 4 into minus 4.5. So we have lambda is 4. So you can just check it. This is right here. So power series method is not, and let me, so you can study power series method by yours, power method and inverse power method. I will try to recall them in the next tutorial, but you can find the, using power method, what you find, the eigenvector and eigenvalues, right, corresponding to a matrix. And to, okay, so dominant eigenvector gives, the power method also gives the eigenvalues and eigenvectors. And what is dominant eigenvector of the matrix? Okay, let's recall once dominant one definition of that. This is not obtained. Show you once. Let me show. Okay, so in this case, you have to find out the dominant eigenvector. So firstly, what is dominant eigenvector? I just show it manually, not this. The eigenvector corresponding to the absolute largest eigenvalue. And dominant eigenvalue is given by the same concept. So dominant eigenvalue is the largest absolute eigenvalue of a matrix. Can you just shut off the mic, Irish? Absolute eigen. Yeah. So in this case, if I give you matrix like this, what is the dominant eigenvalue? Can anybody?
3.
Yes, 3. So you can just find out the dominant eigenvalue and corresponding eigenvector you can find out. Can you find out the eigenvector corresponding to eigenvalue? So if lambda is eigenvalue, then A minus lambda I x is equal to 0, right? Then x is, okay, wait a second, I just want it. Ax is equal to lambda x. And x lies in, x belong to null. Okay, I should use this condition. X such that, okay, x belong to null space of A minus lambda I. So if you have to find out the eigenvector corresponding to lambda, then you have to find out the null space of A minus lambda I.
Sir,
But
please
it's,
scroll down the. I've noted down the definition of dominant eigenvalue and eigenvectors.
okay, wait. Yeah, tell me.
Yes, sir. Thank you, sir.
Okay.
Yes, sir.
All right, now I go to, but this inverse power method, I will tell you maybe in the next class. What do you mean by spectral radius of A transpose A? Have you heard about this term, spectral radius, in the class?
The largest
It's
eigenvalue.
eigenvalue, right?
Largest eigenvalue.
Absolute, right?
Absolute largest eigenvalue. Okay.
Yeah, so that is a spectral radius. So try to find out what is A transpose A in this case, and let's see. Okay. So A is question number. A is. So is there any question on power series in this assignment? Has anybody tested? Sorry, power method.
Question is there. Question is there, but we don't know the. I don't know the answer. It is not. It is not
How many
covered in the
questions
last
are
week.
there?
Let me tell you.
Sir,
Power
one
series.
question, question number 6.
Question number 6 is
6.
there.
Yes.
Okay. So in power method. So what I suggest is just try to look at Gen book. This book. And there is, it's not opening right now. Otherwise, I will explain it maybe. Oh my. Yeah, it's having some problem. What I suggest is you go to Gen book and try to find out the power method and study. It's not so hard, right? And if you have to do an MCQ, I just given. What is the question specifically? Can you tell me? Specific question. What is that?
I'll read out.
Yeah.
What is the approximation of the eigenvector corresponding to the largest eigenvalue of the matrix? Matrix is given using the power method with scaling after 3 iterations. And there is an initial guess given 1, 1, 1.
Okay. We're scaling after 3 iterations.
Yeah,
Okay.
whatever. You have shown one problem, no? Sometimes back. Exactly.
Yes.
Similar
It's
problem.
similar to that. But yeah, you can check by that way. But you study power method. That's good for you. But you can verify your answer in that way also. It's not a big thing, right? Okay, like AX is equal to lambda X. You just try to find out the value of lambda, right? If that is the case. Okay, 1, 1, 0. I just discuss assignment problems maybe. It's 1, 1, 2. I'm not solving them, but what is A transpose A? Try to calculate it. Do you know transpose and all? You just calculate it and tell me. Then I will discuss assignments maybe. Yeah.
Two three zero 351 016.
230. Is it?
351 016.
Is it right? Okay. So what is the okay, just try to calculate the eigenvalue of A transpose A. Okay, so how do you calculate it? So you just, yeah, what is the determinant of this?
Just to confirm, A transpose we have to start in the beginning, you know, like it should be A transpose A means first A transpose should be there multiplied by A.
Yeah.
Or is it A transpose A? I'm really sorry.
Yeah,
Okay, I
yeah.
have told you A transpose. I am really
Yeah.
sorry.
Oh, okay.
Just
Just
pull
change
down,
it that way. It's just tell me again.
Sir, it is 3, 2 minus 1.
Wait.
Sir, in
3,
row
2.
format, 3, 2 minus 1. Then second row is 2, 6, 4. And third row is minus 1, 4, 5.
Okay. So I just change it 3, 2, 6. So you can calculate the eigenvalue.
Sir, I have calculated by using MATLAB, sir.
Yeah. What
It,
are those?
first value is 0.000. Second is 4.3542.
0.0. What is
Yes,
it?
sir,
0.
means 0. That means 0.
Lambda 2
Second,
is?
lambda 2 is 4.3542.
Yeah. Lambda
And
3
third is
is
9.6.
9.6.
9.6458.
Yeah. Okay. So yes, lambda 1, lambda 2, and lambda 3. Okay. So is this matching your answer? Is it? 7 plus root 7. What is this?
Sir, please confirm it by someone other.
Okay. Anyone other?
It's matching 9.64. Option is matching 7 plus square root 7.
Yes. So yeah. So it's C option right here. Just check. Which of the following are true about symmetric matrix? Okay. For symmetric matrix would be square matrix. Eigenvalue of real symmetric matrix should be a real number.
So can
Which
we see the
matrix?
answer just once again? Final,
What?
sorry for
Yes.
that, the earlier answer. Yeah.
Okay.
Okay, please. Yeah, go ahead.
So which of the following is true about symmetric matrix? What is a symmetric matrix? Anyone? A matrix is symmetric if A transpose is A. Yes. So eigenvalues, of course, are real number. A real matrix should be square matrix. It should be square, right? If matrix is invertible, then inverse is also symmetric matrix. Is it true? C option is true or not? A transpose inverse is what is the A transpose inverse? Is it A inverse transpose? Yes, I think so. A inverse. Yeah, so it's just. So so if A is matrix
So
given
it is
by this.
all of these. Yeah?
Yes.
Answers. Yeah.
So in this question, 10th question, A matrix is given this. And what is the spectral radius of T inverse L plus U? Can you identify what is the iteration, which method iteration matrix look like this? Gauss-Seidel, Gauss-Jacobi, which one? Which one looks like this?
Jacobi.
Jacobi, right? Yeah. So you try to find out D L, what is L, what is U in this case, and what is D. Okay, let's see that. So D is 2, 2, 2, 0, 0, 0, 0, 0, 0. What is L? L is 2. Okay, 0, 0, 0, minus 1, 1. Why there is so noise? 2 minus 1 minus, okay, minus 1, and u is 2 minus 1, 0, 2 minus 1 minus 1. Is it right? Okay, so it's not. My God.
Excuse me, sir.
It's not right actually.
Sir,
Yes.
sir, here I am unable to understand why you are saying that. Why you are saying this is Gauss Jacobi?
What? Okay, let's recall this. I'm just going back. Have you seen the Gauss-Jacobi method before? You can see this. How does it look like? Which is method? Okay. This is Gauss. So you look like this matrix H, right? In the Gauss-Jacobi method. Is it same? Only negative sign, okay. Otherwise, it's same. I hope you understand it.
Okay, sir. Okay.
So once you have LDU, you just do the same way, like you just find out this T inverse L plus U. So for any matrix A, you should know how to find the LDU. And once you have LDU, you can apply Gauss-Seidel, Gauss-Jacobi, any method, right?
Just one doubt.
Yes.
Actually, in this, there was no diagonally dominant. No, A was not diagonally dominant.
Wait
So
a
any
second.
switching is required.
A is not diagonally dominant. Why it's not yes, it's not diagonally dominant.
Second
Yeah.
row, second row. So
Mhm.
because that is one of the sufficient necessary condition, right?
Yes, it's the necessary condition.
Yeah.
Yeah, you can switch. You have B, right? You can switch it. Yes. So if you switch it, is it possible? No, it's not B because this row is creating some problem, right? So
Yes,
if you have
yes.
2, 2, 2, then you just have 1, 1, 1 also. So it will never be diagonally dominant, is it? This matrix.
Yes.
Or you can never change it to. So what I suggest is to find out the iteration matrix in this case and check the eigenvalues of iteration matrix. Like this T. What is the spectral radius of T? If it is less than 1, then we say that this method will always converge. All right. Are you getting?
Eigenvalue of the
T.
matrix A, right?
Eigenvalue of T.
Of the T, of the T. Okay.
Yes, because it's iteration matrix. Minus of some minus T. So the eigenvalue of minus T. In fact, absolute. So it doesn't matter. Yeah. Have you got it? So in order to check a matrix for a given matrix, the Gauss-Seidel or Gauss-Jacobi method converges or not, just try to calculate the spectral radius of the iteration matrix H or T. Here it is T. But you can check for the iteration matrix. And if this is less, this is a sufficient condition, not necessary. Means it is always necessary and sufficient, but diagonally dominant is only necessary condition. All right. And you can check it.
But when the matrix itself is not diagonally dominant, can we
Yes.
go ahead with this method itself?
Yes.
Or still we need to check the condition that T inverse into L plus U?
Yes, you have to check it.
To check
Yeah.
that, right?
Yeah. It's only necessary condition. Diagonally dominance. But in the question itself, it should be given. If in this, like, if there are some options, then you need to check it. Yeah. Okay. So, yeah, so let me discuss some assignments now.
Sir.
Yes.
Sir, what is the meaning of converge in the case of matrix? I'm not getting this point.
What is the meaning of convergence? Okay, let me go.
In case of matrix, like in
Yes,
these
yes,
lectures.
yes. So in this book, you can see the convergence analysis, okay? To discuss convergence, we study the behavior of difference between exact solution and an approximation. So you just try to find out the exact solution and approximate solution and try to calculate the difference between them. That will be given by error, and that error we should converge it to 0. That is what we mean by convergence, right? Here EK. And are you getting?
Yes, sir.
Okay. So it's just like that. Okay, let me discuss some assignments problems. How does it look like? Some questions for. So first question is on Gauss-Jacobi method, right? You can do that. Second on Gauss-Seidel method. Third on diagonally dominants. Fourth on convergence of Gauss-Seidel method. Fifth on eigenvalues. Okay, what is sixth question? Sixth question is also on eigenvalues. And seventh question is on spectral radius. Eighth question, I don't know about eighth question. Ninth question is about Gauss-Jacobi method. Right. So all the questions are covered, right? Except
So
the
what
power
is
method.
about question number 9?
Let me check it. Yes, what you want to ask in question number 9? What is the question?
So what is the range of which the Gauss-Jacobi method necessarily converges? So what is the meaning
Yes,
of
so
range
what you
here?
have to do? What you have to do, like? Anyone? Anyone tell the 9th question now?
The convergence criteria is this uh,
Yes, Mayuresh, what
the
you
yeah, probably the one which we have discussed no just now, d inverse into L plus U.
Yes.
So yeah, with
So
that we will find out the eigenvalues, and that
yes.
we will set it to 1 max.
Yes, yes,
It should be less
yes.
than 1, and we'll solve the equation.
Yes. Strictly less than 1, it should be, right?
Yeah, strictly less than 1. Yeah.
So you got it? Anyone who has asked?
So please
has asked?
again confirm it.
Yes, I am saying that if you have to check the convergence, then you just try to calculate the iteration matrix and put the eigenvalues less than 1. Spectral radius. All right?
Okay, sir. Okay.
Yeah. So you go this book MKJan and you will see this, everything in this book. Go to that book. Now, if anybody has any questions, can ask, and yeah.
Just to clarify, probably this is that regarding one spectral radius.
Yes, yes.
What we have done in that worksheet, probably in the worksheet.
Yes.
There we have done the determinant with finding the eigenvalue of A transpose A.
Yes.
So when we do that, actually that it will be something like a lambda quadratic equation will come in that, right? Like we have to solve for lambda.
Yes.
Okay, okay. Because since I think my other
So you
person has
have to
done
find
that.
out the eigenvalues first. You can't find out spectral radius without eigenvalues.
Yeah, got it. But the spectral radius you have written as a determinant, right? Determinant of
Yes.
minus lambda, like so that will when you say take the determinant, it will end up in a equation, like in terms
Yes.
of lambda quadratic
Second
equation.
order, third order, yeah.
Oh yeah, second order, third order. So in that we have to find the value of
Roots.
lambda. Yeah,
Yeah.
roots. So with that roots, we can finally spectral radius. We can directly declare that that is the value, like eigenvalues
Maximum
of
absolute.
maximum absolute. Okay, okay,
Yeah.
okay. Okay,
So
because since it
you
was done, yeah, I was doing it manually. It goes
Yeah.
like a cubic root. Since the other person did it, I think in MATLAB, I think it has come out quickly, the answer. Probably in a quadratic equation, if you do in a
That
cubic
takes
root, it
time,
takes
right?
some time.
Yeah.
Yeah.
So is this like in calculators you can't do it?
So calculators are not allowed, na? They are
And in
telling that.
scientific calculators, it's not easy to do, is it?
Oh, yeah, I know. Scientific calculators we can do it, but manually also we should. Okay, no issue, no issue. I just asked
Okay.
that much only. So it should be like dominant value, or can you please repeat again that a transpose is
Maximum of absolute of eigenvalues. Maximum.
maximum of absolute.
Take absolute of all eigenvalues, absolute value of all eigenvalues, and take out the maximum from them. That would be the. Yes. So have you done these methods? Value decomposition, Cholesky method, last time. Have you done that?
Cholesky, I think it was in the class lectures, it was started.
In the previous assignment, it was based. Some questions were based on that.
Yeah, that was done. That was.
You were done that. Okay.
Yeah.
So you are, so everyone is aware about the methods now. We have, I think they have completed the matrix part and by that roots part. Okay, so the roots of the equation part using different methods initially, and then this matrix part. And I think the next assignment is based on which thing? So this will be different topic, right? A little bit. So we will proceed to some other assignments later on. And this
Sir,
matrix is finished. Matrix theory is finished. Yes.
sir,
Yes.
sir, in Gauss-Jacobi method, sir, I told about how we start the process. We take initial guess like 0, 0 or 1, 1. And after that, sir, I told how to stop. And for this, sir, I told the concept of error is equal L2 bracket xk plus 1 minus xk. And here, sir,
Yes.
I told about L2 is norm. Please clear this. What is the meaning of this?
What is the L2 norm?
Yes, sir. About means, sir, has told about the process where we can stop the process. And for this, sir has take error is equal L2 bracket xk plus 1 minus xt. Yes.
Yeah, so he's saying that if you want to stop the process, just take the error between the first latest iteration and the immediately previous iteration, right? So I just show you once. Okay. So what is xk? Is like x1k, x2k, right? And xk minus 1 is the previous one, right? Then how do you calculate L2 norm? It is xk and so the L2 norm over 2 I just write is basically of summation xik, so it is this xi. You got it? This is L2 norm. And it should be less than some number a, whatever you prescribe. I think sir has said like this, is it?
Yes, sir. Yes.
You just try to calculate L2 norm between two vectors. You should know the definition of L2 norm between two vectors. Have you studied matrix norms? How many types of norms you have studied in matrices?
Sir, here what is A?
A is any number. It's
Which type
just
of number?
You have to prescribe to stop the iterations, right? Like that's the 10 to the power -3 or what?
Means like tolerance.
Yes,
Okay.
kind of tolerance that you do in the roots when you find out the roots. Yeah. So one thing also I would say that have you studied matrix norms?
No, sir. No.
You don't study?
No, sir. And there is a one question, question number 10. There are 2 or 3 options. Please clear it.
Which on matrix norms?
Yes, sir. Question number 10, option second, third, four.
Wait a second. What are the types of norms are there? Question 10 is what?
Question 10 is which of the following statement is not correct?
Yes.
So first option is sir, not related. Yes, sir, related. No eigenvalue of a matrix A exceed the norm of a matrix.
Okay. So you have to just do it yourself, right?
Here, what is the concept of norm of the matrix?
Okay, I just show you this. The norm is like norm of matrix. So there are some norms like A1 norm is maximum of row sum. So in this you calculate this. Suppose this is the entries. Right? Then you calculate the first row sum, second row sum, last row sum, and take out the maximum among them. That would be the maximum of row sum, okay? And another one is maximum of column sum. I think A2. Maximum of column sum. There are some other sums also, some norms. There is also, wait a second, I just check it. There is another norm. So what is the definition of norm? Just look at that. Like what, if you want to check what is the norm of that, let's try to find out. Frobenius norm. Okay, there is one more norm, Frobenius. Okay, so Frobenius norm is AF, which is just B. Okay. There are different norms depending on, but maximum of row some people use first. All right.
Okay, sir.
Anybody? Yes, now tell me. Yeah, any questions? Only 3 people. Last time it was 15. How they? Mayuresh, have you sent me some questions?
Yeah, I mailed you,
Let me check you.
couple of
Okay.
times, and no, not
have
for this assignment, last assignment, and I got help from you. Thank you.
Okay, have you done that?
Yeah, last assignment it was
Okay,
all
okay,
right.
okay,
Based on
okay.
that, I could do something.
And about the Shravan, have you mailed the tutor regarding? Okay, I forwarded your email regarding the wrong questions. Have you got the reply over that?
reply is there, but it is correct spell error, like typo error. But I
Okay.
don't know whether that any correction will be given for all.
Oh,
It is about which question, Sarvanand sir?
It is on the the week 2 assignment. Just one second.
Okay. That I also got it wrong.
Yeah.
I
So
also
it
got
was
it wrong.
so it was told like it is an error in the typo. That is absolute and approximate error was there, no? So that question was answer should be
so what
absolute,
she
but it
says,
was
what she has said.
simply it is a typo error, ignore.
Okay. I've uploaded the previous videos. I think you have seen them if you have not attended.
Just anyway, just since some time is there. This again, I am coming back to that same determinant of this lambda, lambda 1, lambda 2, lambda 3. Three values we are referring, like lambda is 0 and the values whatever we have shown 9.63. But when we solve the quadratic equation directly, like this equation, like third order equation, we are getting something like 10 point, the final value. So
Okay.
maybe how
So
that
what I
different
would suggest is you don't find them manually. Maybe you go by power method
power method. Okay.
in this case. Yeah,
Okay.
let's start with something.
So
Numerical
power method
approach.
probably I think we have to see from that Jane, I think. Yeah.
Yes. Just see
Okay.
that. Okay, now I'm stopping. Thank you. Bye.
Okay, thank you. Bye.
Thank you, sir.
Stop the recording.